Hello everyone. In this video we're going to go over some basic formulas from section 6.3. In section 6.3 we're going to be looking at finding the volumes of different solids using a method that is described as slicing. So in some of the other videos that you'll see this week that are put out by the publishing company, you'll have some really great diagrams that are interactive, and you can kind of see what we mean by taking a two-dimensional figure drawn on an XY axis and rotating it in order to create a solid that we are ultimately trying to find the volume of. And again, the method in general is called slicing, because what we're going to do is we're going to take slices of this three-dimensional solid and we're going to find their volumes repeatedly as n goes to infinity, as the number of slices goes to infinity, which produces an integration. So the three overall methods are general slicing method, disk method, and washer method. So as far as formulas go, the general slicing method is one that we are not going to use as frequently as the disk and washer method, but I will go over the formula anyway. So basically, if we want to find the volume of a solid, that solid can be drawn or can be created with a two-dimensional figure that is either perpendicular to the x-axis or perpendicular to the y-axis. Either way, what we're going to do is we're going to integrate the area function of that two-dimensional figure over some interval from a to b. And we're going to take that two-dimensional figure and again either rotate it around the x-axis or the y-axis to create this three-dimensional solid. When we do the integration of the area of that 2D figure, we will get the volume of the 3D figure. And the area function will depend on what shape we have. So if you have a two-dimensional rectangle drawn on the x and y-axis, then obviously length times width will create an area function. If you have a circular region drawn, a circle, as your two-dimensional shape, then obviously pi r squared creates the area of that function. So your a of x depends on what shape you have. So that's the general slicing method. Again, less useful than the disk and the washer method. So let's go on and talk more specifically about the disk method. So for the disk method, it's going to depend on whether we're revolving our two-dimensional shape about the x-axis or whether we are revolving it around the y-axis. So each of these scenarios will produce a different version of the volume formula. You'll see that they have a lot in common, but they also have a slight difference. So if we're revolving a two-dimensional shape around the x-axis, and we're going to use the disk method to find its volume, we're once again going to integrate over an interval from a to b. And what we're going to integrate is pi times f of x squared. And dx means with respect to x, which makes sense since we're revolving around the x-axis. If we're revolving around the y-axis, then it's going to look very similar. We're going to have pi, but instead of having f of x, we'll have some other function p of y squared dy. So I'll talk briefly about where this comes from. I think some of the videos that the publishing company puts out this week for this section give a nice clear picture of how this comes about. But pi r squared represents the area of a circular region. And so a disk is like for example, a frisbee. If you've ever thrown a frisbee, it's in the shape of a disc, sort of, with a little curve added to it. But in general, discs are circular shaped objects. And so we're using the area formula pi r squared here, where the radius is created by some function f of x. So pi r squared gives us the area of that circular disk region, and we're going to integrate it in order to get its volume. Same thing down here. Again, we're just revolving around a different axis, so our radius is formed by a function called p of y instead of f of x. Be very careful here, you're squaring the whole function. You're not just squaring the x on the inside. Again, you're squaring f of x. Okay. One important thing to note here is when you have to revolve around the y-axis, then you are going to need to rewrite your function in terms of y. So if you have a function y equals x plus 3, you'd have to rewrite that so that you have x equals y minus 3. You'd have to reorganize it so that it's solved in terms of y. Alright, so there we have disk. Let's talk about washer. So washer is similar to disk in that it's circular in shape. But if I could draw for you here a disk, that would again look circular just like that. A washer, and maybe you've seen a washer before if you've ever worked with tools, nuts and bolts and things like that. Not that I'm the expert in that area, but a washer looks something like this, where we've got an outer radius and an inner radius, kind of creating this donut shape. So this happens when you have two different functions that are creating the radius of your two-dimensional figure. So that does change our formula just a bit. Again, we want to consider what happens when we revolve about the x-axis, as well as what happens when we revolve about the y-axis. So here we're going to be finding the volume, integrating from a to b. Pi times f of x minus g of x. And we're squaring each piece. So again, we're looking at a pi r squared type relationship because we're working with something circular. But you'll notice here that you have two different functions, f and g, that are each being squared and subtracted in order to show or to find the length of that radius. Okay? So your outer function here might be f, your inner function here might be g, and if you subtract them, you're going to get your radius. So we've got this formula, and of course we need to show that it's with respect to x. It's important to note here that the f will always be the larger radius or the outer radius, whereas the g will always be the inner radius. Okay, so you want to think about your functions, and the larger function, or the function on top, will be your f, and the function on the bottom, or the smaller function, will be your g. Very similar if we're revolving around the y-axis. Again, we want our functions to be in terms of y instead of in terms of x. So here we'll have p of y squared minus q of y squared dy. Alright, one other slight variation that we might see in any of these methods is if we want to revolve, and we'll specifically refer to disk and washer. So if we want to revolve about an axis that is parallel to the x or y axis. So typically, in the beginning examples, you'll see the revolution happening about the x or y axis itself. But as you've tried a few of those, we'll start to expand our thinking and rotate or revolve these two-dimensional figures around, say, the line y equals 1. So I'm going to put that down, y equals 1, for example. Or x equals 5. Or y equals -2. So any vertical or horizontal line, they're still parallel to the x or y axis, but they're not specifically on the x or y axis. So what we'll want to do here is we'll want to pay attention to how we get the radius. So we're going to calculate the radius in these examples, and I honestly think that it really helps to pull all this together when you can see a really nice diagram, and I can't draw those. I could try, but I think that the videos that you'll see that the publishing company puts together digitally are going to be much more helpful in terms of strengthening your understanding. So we are going to again calculate the radius by taking the line of revolution and then subtracting the curve. So you'll be given some curve function that creates the boundary lines for the two-dimensional figure. And so if you take the axis of revolution and subtract the curve, you're going to come up with a distance that represents the radius of your disk, for example. Alright, so that's an overview of each of the methods of this section. What you should do now is go ahead and view the videos that are provided by the publishing company. You'll see one, let me just outline the videos that you'll see. You'll see one on the general slicing method. You'll see a second one that is on the disk method. And then you'll see a third that's on the washer method. So each of these disk and washer videos are going to show you examples of where we're rotating our solid around the x-axis. So take a look at those first, and once you have, I'll come back and I'll continue more of my lecture where I'll show you an example of the disk method where we are rotating about the y-axis, and I'll also show you an example of the washer method, where we're actually going to be rotating around a line that is parallel to the x-axis, which is going to be the line y equals 1. Alright, so go ahead and stop here, take a look at the videos that are provided by the publishing company on Canvas, and then you'll come back to one of my videos to finish out section 6.3.